Hej och välkomna till ännu ett intressant webbinar med oss på Ramen. Jag vet inte om vi ska vänta en liten stund och vänta in fler deltagare, övriga deltagare. Men vi kör igång. Så agendan för idag, det blir först att introduktionen blir på svenska utav mig och sen blir själva presentationen på engelska utav Lorraine. Så tveka inte om ni har frågor att ställa dem, så kan vi ta upp dem efteråt eller senare i personlig dialog. Och alla deltagarna kommer att få presentationen efteråt och mötet spelas in. Sen kommer det även vara en liten enkät där man får ta fram sin telefon och scanna QR-kod och svara på ett par enkla frågor som även är anonyma. Det blir ett spännande test och ni är då som sagt välkomna att ställa frågor efteråt för en fördjupad dialog och förtydligande. Så agendan idag blir princip detta, grundläggande principer för ångreglering, kondensat och backventiler, ångtrycksreglering, övertrycksskydd, vakuumskydd inte minst, bästa praxis för avstängning och sen blir det kort om ångfällor. Och vi som håller presentationen, det är jag, Daniel Bonväng, och jag har lång erfarenhet inom ventilbranschen, framförallt reglerventiler och kritiska applikationer och gett många kunder med applikationer inom ånga bland annat. Och det är Lorraine som kommer hålla i innehållet i presentationen. Han är vår tekniska ventilspecialist och han har lång erfarenhet inom ventilbranschen sedan 90-talet. Jobbat mycket med tryckregulatorer, tankskydd för cisterner och sen givetvis alla övriga ventiler. Och Ramen, vi är ju en liten svensk firma med omsättning på 60 miljoner. Vi är 12 anställda. Vi har huvudkontoret i Bromma i Stockholm och sen så säljer vi våra produkter ut globalt i hela världen via återförsäljare. Och vi har ju våra egna produkter och vår egna verkstad i Fagersta där vi har lager, produktion, service och support. De produkter vi säljer är ju först och främst våra egna KS-ventiler som ni ser på bilden. Det är en kulsektorventil som vi har haft sedan lång tid tillbaka, sedan 1968. I många olika applikationer. Sen har vi våra vakuumventiler, backventiler och sen övriga reglerventiler från mikroventiler till stora för ångapplikationer och pannanläggningar. Och vi bidrar ju med de här produkterna, vår expertis och där vi hjälper till med rådgivning, erfarenheter och beräkningar. Och sen har vi vår serviceverksamhet och underhåll i Fagersta. Vi säljer även agenturprodukter som Hirose för hygien-applikationer, cashbot, tryckregulatorer, badger som är doseringsventiler. Och vi har bred erfarenhet och brett verksamhetsområde från marin- och offshorebranschen till papper och massa, många applikationer. Energisektorn, bland annat gasapplikationer, olika former av energigaser och hygiena gaser. Kemisk industri och petrokemiindustrin. Och gruvnäringen, inte minst med sliten media och livs- och läkemedelsindustrin. Så det finns en lång och bred erfarenhet. Och vi hjälper då till med vår expertis och vår service- och underhållsverksamhet som ni kan dra nytta av, där vi provar ventiler, där vi provtrycker ventiler, läckagetestar dem, kalibrerar och monterar och lämnar kompletta paket. Och vi är också auktoriserade vi är en auktoriserad serviceverkstad för Hirose. Och därmed så lämnar jag över till min kollega Lorraine. So please Lorraine.
Good morning. Yes, I will be in English, and I hope it is okay with you. And we have a quick survey that we want to run, and I trust it would be good. It is just a quick scan with your phone. Just scan the QR code. And from the QR code, there will be 2 questions, and it is anonymous. And if you could quickly do that for us, that would be very great. This is just to have some interaction here. So yes, I've got one. So let's see. Cool. 8 respondents, 7, 8. Good. Next slide. I'm going to do the next slide. You can answer the next question. Oh, thank you very much. 7, 8, 9, 10. Now, when you finish responding, then what happened is you can actually see the results, and the results is actually 0. There's one in. I cannot read this, but you will see the results. Good. Let's go on. Very interesting. People really knows this steam stuff, so let's go into it. So steam is one of the most common utilities in the industry, yet it is often taken for granted. As you will know, that valves are frequently selected based on habit because we don't have time. We say this valve goes there, just select that one, it will work. The result is sometimes it is unstable control, noise, wear, unnecessary downtime. But Raman is already active in the steam industry, and today we want to make it visible for you. And this webinar will show you where you can benefit from the knowledge that we have. This is a basic steam system, as you will all know. There's a boiler, there's pressure control systems, or pressure control reducing stations, steam controls, valves, there's vacuum breakers, safety relief valves, and your steam conditioning equipment. And obviously then there is your process equipment and your plant systems that you need to control, that you need to use the steam for. So when we want to talk a little bit about steam control, and we mostly refer to steam control in terms of the control valve. So when we control steam in heat transfer systems, the purpose is to regulate heat transfer. In most industrial steam heating systems, pressure control is used instead of temperature control because saturated steam temperature is directly determined by the pressure. As you all know, when steam condensates, it releases heat and at a constant temperature. So maintaining a constant pressure reduces the stable, ensures a stable heating condition. So when we reduce 19 bar steam at 212.5 degrees Celsius to 15 bar steam, the temperature drops to 201.5 degrees Celsius. So pressure control at saturated steam is instantaneous, and temperature control reaction time over the period to maintain the same amount, to get the same temperature at the specific pressure. So the rule of thumb, control pressure when steam is saturated and used for heating via condensation. For example, tire curing presses, heat exchangers, steam jackets, autoclaves, dryers, reactor heatings, food sterilization. And use control to control the temperature when the steam is superheated and when product temperature is that matters. So as an example, in a tire curing system, steam temperature is controlled indirectly by regulating steam pressure. Because saturated steam temperature is uniquely related to the pressure, as we already discussed. A pressure control loop provides faster, more stable control than a temperature control loop. So where lies the problems in steam control? So we identified basically two. First of all, your valve sizing and selection. And it's not just control valves, it's all your valves in your steam system. And secondly, it is your quality of your steam and the management of your quality of your steam. So poor valve type selection is another very common mistake, is by using the wrong type of valve in the application, trying to control steam by using a ball valve or a butterfly valve for steam control, where it's actually supposed to be for on-off service. It results in poor control, instability, and valve damage. For steam control, in most common choices, a proper steam control valve is the better option because they provide good throttling and very stable control. Sometimes using a pressure regulator when a pressure control valve is required. The correct approach is use a control valve with a proper PNID loop. When the process load changes frequently, precise temperature control is required. The system is large and or critical. So incorrect valve sizing, usually oversized sizing because we are choosing the valve based on the maximum load. The valve should operate around 40 to 70% open at normal conditions. It is always advisable to, when supplying your valve supplier with process condition, is to also supply the minimum flow rate or the minimum conditions that will result in a minimum CV. This way, you can easily determine a better or select a better valve for the application, knowing the maximum as well as the minimum conditions. Then sometimes ignoring critical pressure drop and choked flow conditions, steam valves can reach critical flow conditions. When this happens, increased valve opening does not result in increased flow. Many engineers forget this. The result is they think the valve is too small, but in fact, the valve is already at maximum flow capacity because of choked flow conditions. Then we have selecting the correct inherent valve characteristic. In most steam control applications, equal percentage is preferred. Then ignored steam quality. So how does wet steam disturb control? So first of all, flow measurement becomes inaccurate. Heat transfer becomes inconsistent. And valve control characteristic changes. Because control valves are sized for compressible vapor flow. Wet steam behaves more like a two-phase fluid. So this increased noise and vibration. Then in steam quality control or steam quality, poor management, poor condensate management. Engineers often focus on the steam valve but ignore condensate removal. A condensate in the line influence the valve, mechanical damage to the valve, wire drawing, and erosion, water hammers, flashing after the pressure reducing station. Result, the valve appears to be the problem, but in real life, it is because of poor steam conditioning. Not considering that flash steam after pressure reduction station. So when steam pressure is reduced, some condensate flashes to steam, and this steam volume increases. And if piping is not sized correctly, the velocities will be high, the noise will be high, and erosion can occur in the piping and downstream equipment. From time to time, a big problem is installing the pressure sensor in the wrong location, because sometimes we don't just have enough pipe diameter, straight length to install it. So the best practice is to install it 8 to 10 diameters downstream of the valve. Yes, so when you hear a noise in a steam valve in the plant, what does that mean to you? And some people will immediately say, yes, it's high flow. But in steam systems, the first visible symptom, or how can I say, the first symptom that you can hear is incorrect control valve, it will be the noise. But noise is not just annoyance. It usually indicates excessive pressure drop, high steam velocity due to high flow, or high pressure drop inside the valve. But when steam is not perfectly dry, droplets of condensate can enter the valve. The pressure drop across the valve, as the pressure drop across the valve, these droplets may partially flash or accelerate to very high velocities. This can create wire drawing effect, like you see in this valve plug here, or gradually eroding the plug and the seat ring. Over time, this leads to leakage, instability, and reduced valve life. So when we hear noise or see erosion in the steam control valves, the root cause is often incorrect sizing, incorrect characteristic, or operating the valve outside of the intended conditions, or just poor steam quality. Just an example of flashing. Flashing is typical signs that you will see on your valve plug will be like when you take a knife through butter. And this would be a typical one like that. So let's go on. So valve characteristics. So valve characteristic in steam heating. Steam control is non-linear. Two key non-linearities is present. Heat transfer rate change with load. Why do temperature loops often hunt more at low load than high load? Because at low load, a small amount of flow changes cause a large temperature change. But at high load, a larger flow change are required to have a similar temperature change. So this results in that the system gain is not constant. So why equal percentage? Well, because of in most steam control applications, equal percentage valve characteristics are preferred. Steam systems experience large variations in pressure drop as load changes. When the valve opens, the system pressure losses increases, but the valve differential pressure decreases, and equal percentage compensate for these changes, providing smoother and more stable control over a wide operating range. Each increment of valve travel for an equal percentage allows for the same percentage increase in the flow. One important factor to remember is, as you see the equal percentage sign curve here, as soon as the valve is installed with the gain that is not constant, you will actually get a more linear curve out of the valve. And this makes it much better to a steam control system. So when we talk steam control valves, we basically break it in, for us, in three parts. One is where you will have a low differential pressure with a high flow, but you require a high rangeability. This is where the ball sector valve is very good in, and it's also standard equal percentage plug, inherent characteristic. Then we have a microflow control valve for small flows and microflows in steam applications where high pressure and high temperature up to 800 degrees Celsius can be reached. And then we also have a normal globe valve where you have high temperature, you have a high differential pressure where noise and high velocities will be present, but you can install with these valves, you can install a noise control trim. So this is a little bit of where we position ourselves. Then we get to check valves. So check valves in the systems, condensate formation is not a problem. It is how the steam transfers heat. But however, where do you think the most condensate form in the system? Only in heat exchangers? No. No. Condensate forms wherever steam gives off heat. Whenever steam loses energy, it becomes water again. This happens not only in process equipment, but also piping, particularly during startup or shutdown. So common locations are heat exchangers, steam jackets, vessels, long pipe runs, startup conditions. The key engineering question is not whether condensate forms, but whether the system manages that condensate correctly. So without proper management, condensate can accumulate and move into the wrong direction. So when steam condensate during shutdown, pressure in that section in the system can drop very quickly. If another part of the system still have higher pressure, condensate can be pushed backwards through the piping. This reverse flow can create a water hammer and often reach the control equipment, valves, flow meters, transmitters, etc., causing instability or damage. A properly selected check valve prevents this by allowing flow in only one direction. I would say a requirement for a check valve in steam is obviously a high temperature, must be reliable sealing, and it must be erosion resistant. Then we get to pressure reducing stations. So industrial boilers typically operate at high pressures to distribute heat efficiently, and the pressure is then reduced at the point of use to match the requirement for the process in that part of the plant. So pressure reducing stations are a common and very essential part of most steam systems. So symptoms of incorrectly sized pressure reducing stations or pressure reducing regulators are pressure fluctuate downstream, hunting or unstable control loops, excessive noise or vibration. Regulators operate mostly near close position. This can cause wire drawing or hunting or chattering even in the valve. The root cause is oversized regulator, selecting a 2-inch regulator in a 2-inch pipeline, incorrect flow estimation, large pressure drops across the valves, and poor steam load predictions. These days, we can accurately size a regulator for your application. It's no need to just choose line size. Why overpressure occurs? So steam pressure can rise very rapidly in a system. So we talk a little bit about safety relief valves because it goes hand in hand with a lot of things in steam. The role of a safety relief valve is to protect equipment, protect personnel, and comply with pressure codes. So if a pressure regulator fails, you can get high pressures and you can need to relieve that to protect your downstream system. Control valve failure, blocked or closed downstream lines, thermal expansion or trapped condensate, rapid load changes. So typical application installations is on boilers, pressure vessels, steam headers, and downstream regulators. A steam system without a safety valve is like a car without brakes. Well, Daniel already mentioned it earlier. Raman is a certified safety valve maintenance company and authorized service partner with Eros in Sweden. And we deliver certified maintenance and service for safety valves. So if you also need to have yours checked and replaced, please do not hesitate to contact us. Then one thing that is sometimes overlooked is vacuum. So vacuum creates more mechanical stress in systems than pressure some of the time. And sometimes as well, before discussing vacuum protection devices, it's important to understand is why vacuum forms in steam systems in the first place. Steam accumulates. Steam occupies a very large volume compared to water. When steam condensates back into water, the volume reduces by almost 1700 times. When the steam gives up heat, it condensates, the vapor phase disappears and it replaces a much smaller volume of water. If no air can enter the system, it replaces and lost volume. The internal pressure begins to drop rapidly. As the pressure inside the equipment drops below the atmospheric pressure, a vacuum condition begins to develop. And at this point, the outside pressure, which is 1 bar, starts pushing inwards on the external walls. This is an important point. Most steam equipment is designed to withstand internal pressure pushing outwards, but it's often not designed to withstand external pressure pushing inwards. This is why vacuum conditions can be surprisingly destructive in steam systems. You can observe the symptoms as pipe deformation, vessel wall distortion, or unusual noise during shutdown, all of which can be indicators that vacuum is forming in the system. There's a simple solution, and the solution is just adding a vacuum breaker that will allow air into your system when the vacuum is formed in your system. So we're going to quickly touch also on isolation valves. There's different types. I'm not going to go into detail. There's standard globe valves, wide type globe valves, bellows sealed globe valves. Then also we have gate valves and metal seated high performance butterfly valves and triple eccentric butterfly valves. Rather than focusing on each valve type individually, it is useful to step back and look at the overall picture in steam systems. Isolation valves all serve the same purpose, to rapidly stop flow for safety, maintenance, and operational control. However, the way they perform that function differs depending on the design. For most process steam applications, globe valves remain the preferred choice because they provide reliable shutoff under high temperatures and changing conditions. When flow capacity becomes more important or pressure drops needs to be limited, a wide type globe valve are often selected, and they offer similar sealing performance with improved flow characteristic. As pipe sizes increase, particularly above the N200, butterfly valves, especially triple offset designs, become more attractive, mainly due to their lower weight, compact size, and lower cost compared to large globe or gate valves. Gate valves are still found in many systems, especially in older installations in last mains, but they require careful use. They perform well when fully open, but can be prone to damage if not operated correctly. In applications where leakage cannot be tolerated, for example, in chemical or high value steam systems, bellows sealed globe valves are often used to eliminate stem leakage. So the key takeaway is that there is no single best isolation valve for all situations. The correct choice depends on the pipe size, the pressure and temperature, required shutoff performance, space and maintenance considerations, but as a general rule, globe valves dominate smaller and medium sizes and butterflies dominate larger lines. So then there is steam traps. I'm not going to go into a lot here, but steam traps are often small components, but they are absolutely crucial for efficient steam systems. Their job is to automatically remove condensate, air, and non-condensable gases, while keeping valuable steam inside the system. If condensate remains in the system, heat transfer becomes insufficient, and water hammer can occur. A properly functioning steam trap allows condensate to leave immediately while preventing live steam from escaping. So, we touched on the basics and how can I say, a helicopter view on the steam system. I want to give back to Daniel and he can take control from here.
Okej, tack så mycket Lorraine. Det var en innehållsrik presentation Jättefint. Ska vi se, hakade min presentation upp sig här. Ursäkta. Okej, tack så mycket. Det var som sagt innehållsrikt och jag välkomnar er att dela de frågor som naturligt kommer fram. Så fort ni har några frågetecken eller frågor så hör av er, så tar vi en fördjupad dialog när vi kan prata om det. Och ni hittar våra produkter på vår produktplattform där ni hittar de olika typerna, alla olika typer utav ventiler. Ni kan välja de olika produkterna och konfigurera dem med artikelnummer, beskrivning, och ni hittar även manualer och datablad och allt det. Så därmed så vill jag tacka för oss och ert deltagande och intresse, och återkom gärna med frågor för en fördjupad dialog. Tack för idag.